So let's put it in 2 words. So we've gone through the whole language portions of it, right? So it's a complete JVM dynamic language, right? 100% interoperable with Java, which we haven't really talked about much, but it's completely interoperable with Java. So that means that you literally almost code like Java. There's no bridges like that exist on current CFML engines, right? We wanted to burn those bridges. We wanted to have full ability to import Java classes easily, to declare interfaces easily, extend from Java classes, implement from Java classes, everything that a dynamic language based on the JVM should do, right? So
ColdFusion Alive, the podcast for the ColdFusion community. Discover practices, tools, techniques, tips and trends for modern ColdFusion development. Brought to you by TerraTech, the ColdFusion experts. Develop, secure, optimize. Here is your host, the founder of TerraTech, Michaela Light.
Hey, welcome back to the show. We're here on CF Live with 2 mega geniuses of ColdFusion, Luis Majano and Brad Wood of Auto Solutions. They're joining us actively Spain and from Kansas. So, and I'm right now in Austin, Texas. So we're quite spread out here. But we're here today to talk about BoxLang, the new ColdFusion engine that joins the stable of ColdFusion engines of Adobe ColdFusion and Lucy. And it's now an alternative to that, which I think, and I'll tell you why I think it's a really great thing to have for the ColdFusion community later. But I'm going to let Luis and Brad talk about that. But before I do, if you don't know who Luis is, he is the founder of Auto Solutions. He's behind a lot of those box products, ColdBox, Wirebox, you name it, box. If it's got a box in it, he's probably had his hands in it, except for CommandBox, which Brad had his hands all over. So, and then Brad is, as I said, the father of CommandBox, but he's been heavily involved in all the box products and does amazing things in ColdFusion land. Both of them are great speakers. They've spoken at CF Summit, which is coming up soon, and Into the Box and CF Camp, and probably any other ColdFusion event you can think of. So welcome, Brad and Luis.
thank you.
Thank you.
Happy to be here.
Yes, I'm very excited. So, first new ColdFusion engine in maybe 14 years. I forget when Raylo came out and then morphed into Lucy, but it's a while. So very exciting. So tell us briefly, just in a short, just what's the capsule overview of what is BoxLang?
Sure. Well, first of all, it's not a CFML engine. So let's start there. Let's start with that one, the big one. So okay. It's not. It's a new language that can actually talk ColdFusion. Let's put it that way, or CFML. Let's not use the ColdFusion word because everybody gets confused between ColdFusion and CFML. So let's say ColdFusion is Adobe, CFML is the language. So let's stick with that one. So BoxLang is a new language for the JVM, inspired by CFML, inspired by Groovy, inspired by Rust, inspired by Python, inspired by PHP, inspired by many languages. So I think there's been a conglomerate of different languages that have really been playing with us as we've been working for more than 20 years in the space. And that's what basically motivated us in several different places for BoxLang. But BoxLang is a new JVM language that can talk CFML.
All right. So for those who don't know what a JVM language is, first of all, JVM is the Java virtual machine that ColdFusion runs on top of, and other languages run on top of it too. So
correct.
Basically, ColdFusion is compiled into Java bytecode that runs in the JVM, or is interpreted into it, depending on how you run the code.
Correct.
So you're saying BoxLang is also compiled into Java bytecode, or
correct.
How's
that? It would be similar to the Groovy language. It would be similar to other JVM languages out there like Clojure and Scala that basically compile down to Java bytecode and get executed in the Java virtual machine. And basically, just like these other languages, BoxLang, it's unique in that sense. Now, the major difference that why don't we call ourselves a CFML engine is that we have no web server in the core. The language has been designed from scratch. The team, we sort of several months basically went through the whole idea of what a new language would look like in 2024 and beyond, right? And that's why we designed the language to be hardware first, right? And that's why it's incredibly small. We wanted to make these decisions not based on a web server or a web application, but based on just the language. And that's how the language core for BoxLang is around 7 megabytes in size and extremely tiny, extremely lightweight. And then we came up with the concept of multiple runtimes that can basically, like an onion, be producing layers around the language according to different deployments or styles, etc. And one of those, of course, is a web server, right? We also have a new concept called the mini server that Brad created as well. We also have serverless, which is AWS Lambda support, which we have created, and upcoming Azure functions as well. The other runtimes could be Jakarta runtimes. It could also be Android deployment. It can be used for Android development. Later on, we'll be focusing on WebAssembly and iOS. But the whole idea is that BoxLang is very tiny at its core, but then depending on where you deploy or where you're targeting your runtime to be, then it can basically expand.
So that's analogous to the packages that happen in Adobe ColdFusion where they add in extra features. But so how would it be different from that? It sounds like you did it a different way.
Correct. So those features that you're talking about are more kind of the modularity of the actual framework per se of Adobe. And for us, we also have modularity as well. So not only do our modules enhance basically the entire runtimes, but we can have different modules for different runtimes, right? So we do have a full modular architecture that we've developed in BoxLang. This is not using OSGI like Adobe or Lucy. We actually created this inspired by ColdBox that we've created for more than 15 years. Actually 18 years now, sorry. So we wanted something extremely lightweight and extremely fast and extremely contained. And we were able to achieve that. We have over 30 modules now in such a brief span of period of time. And so that's the difference is runtimes are completely different. This actually allows you to run the language in different hardware and different software deployment avenues. And then our modules basically enhance the language and more of its framework capabilities, right? And this could be from ESAPI modules to PDF, document services, FTP services, etc.
Yeah, I would say that one of the biggest differences is our modularity goes to a much deeper level. The other CF engines, started as just, both of them started as large projects that incorporated all the features that CF offers, and then the modularity was added later, where they kind of broke those pieces back out. And so we've learned a lot about that over the years, and we started from the beginning with a tiny core and the module pieces, but our modules aren't just for pulling out the PDF tag or the SAPI functions or the ORM functionality. We broke apart the very core most of a language to be just the pure language all by itself, like you would run Python from the command line. And then, all the web functionality is a separate piece, which isn't part of the core. And the AWS Lambda is a separate piece that's not part of the core. So at the very smallest level, we've been able to break that out. And one of the problems in the past, if you wanted to use CF in an AWS Lambda, you had to deal with the fact that the installation could be hundreds of megabytes and could take, several seconds to start up. And that's why, we wanted to be able to have these runtimes that have all the unnecessary pieces stripped away. And, that's why we have a 6-7 megabyte jar that can start up in just a couple hundred milliseconds. Because, CF just wasn't functioning where we needed it to for some of these deployment targets, and people weren't able to use it there. And we wanted to be able to, bring it to that place, but that required some drastic architectural differences in how we started with just absolute, minimum functionality in the core, which also even goes down to the third-party Java libraries we incorporate are incredibly minimal. That gives us a smaller surface area, fewer vulnerabilities that we have to deal with in third-party libraries, and it just keeps everything as tight and compact as as possible in the core. And doing that from day one, starting with an empty repository and just building from scratch as small as possible, kind of helped us focus on that small, lightweight runtime to be able to compete a bit more easily with a lot of the other languages out there. You have, Node and Java and Python, and you can just do these little, tiny command line, executions of things. I mean, we wanted that in BoxLang, but obviously still having the add-ons to be able to, support everything CF does.
That's great. So just for folks listening who may not understand how big the core is currently in Adobe ColdFusion 2023 or the current version of Lucy, do you happen to know how big their minimal core is?
Yeah, it's a tricky question. It depends on what modules you include.
No, I think
I assume you have no modules. Cool.
Well, so
No
I'll answer
modules
both
added.
questions. Before ColdFusion went modular, the WAR file was about 300 megabytes when it included everything.
Oh.
And the Lucy WAR file that included all of the extensions was around maybe 120 megabytes. But OSGI was always a kick in the pants because with OSGI, you have 2 to 3 copies of every single jar that get kind of put around your hard drive. And that's another big difference. We don't have this sort of giant installation folder with like hundreds of jars and files that kind of expand. Lucy could be upwards to 200 or 300 megabytes if you had all the extensions and you included all the runtime caching and OSGI bundles, because you would have every OSGI bundle would be in the Lucy jar, it would be in the bundles directory, and it would be in the Felix cache directory. And so you'd get this like multiplication of 3 sort of explosion that OSGI did. Without the modules, Adobe ColdFusion 2023, their WAR file, I want to say, is down to maybe 120 megabytes. I can look it up. I have it in my artifacts here.
Yeah, we'll update it in the show notes on
Just
the Paratext
also
site.
to compare with the other languages, Node, for example, is about 80 megs. So
yeah, and then
perspective as well.
Lucy, just the core jar with no extensions, is pretty small. It's down around 20 megabytes before you start it. But again, once you start it, it balloons back up to about 70 or 80 megabytes because of all the jars that get spread around from OSGI. So our core jar is 6 or 7 megabytes. And most of it's designed to not unpack a bunch of stuff all over your hard drive. It's pretty self-contained. You can just say, java-jar BoxLang, and then you can, run a file directly. And we have a handful of conventions as far as a place in your home directory you can put a config file and where some log files will go and where you can install modules. But generally speaking, we try to keep everything just as self-contained as possible, like a more traditional Java application where you download a jar, it kind of has everything you need.
Okay, so it sounds like you're at least 10 times smaller than a typical Adobe ColdFusion or Lucy runtime.
Well, actually, yeah, the current WAR file I have for 2023 is 169 megabytes. It's bigger than I thought it was.
Yeah. Well, maybe after the show you can dig into what those numbers are, because I think that's good information for people interested in BoxLang, how much more efficient you actually are.
I think the kind of the main point there to follow up on Brad is it's not only about size, right? It's not like, oh, this one's smaller. Right? I think the important thing to address for us was that we had the luxury to really sit down for months and design what we wanted, right? To really design what would be the most viable product, basically minimal viable product that you could have as a language design from the operating system point of view, right? And then build upon that for the different runtimes that we could target, because that gave us the capability that we could deploy runtimes down the road in any way and capacity without restricting us to changing things. Right? So we wanted to be extensible and change things very quickly by just extensibility, right? So I think that was our main intent there, is to make sure that we were flexible enough for the future where we're not stuck with a monolith, right? We wanted to make sure that we could grow it organically, right? And be able to to have these modular systems in place, not only for extending capabilities, but also for the runtimes themselves, right? Which is not like before, right? Before, where only web servers were available, right? So in our case, this is what we wanted, right? We wanted to be operating system first, right, at the lowest level possible, and then keep growing depending on the needs of developers of where they wanted to deploy their BoxLang source code, right?
So
and
you
we were also
Go ahead.
Just to point out also, the last one is that we're super strict also on third-party jars. And I think that this has been a mishap, for example, of other frameworks and engines, is that they basically, any single Java library available, they include it, right? So we're extremely meticulous on what to bring into the core, and that's why it's so tiny. Because there are a majority of things that are available already in the JDK now, because it's so modern, not like before. So I think that has really benefited the project, because we don't have to basically bring in every single jar file out there just to bring certain capabilities in.
Yeah, and that's really a huge thing that Luis just touched on, because Java used to be kind of like Internet Explorer, right? You'd get a new version like every 5 years, and it didn't really do a whole lot. But, in the last 10 years or so, Oracle's really done a lot of stuff with Java. After, Java 8 was a big, giant, stable stopping point in the Java world, which was a great release. I had a lot of stuff. Invoke Dynamic is as old as Java 8. Streams came out in Java 8. And since then, starting in Java 9 is when they introduced a lot of new modularity into the core, and they've started making changes, breaking changes, adding features. And there's a whole bunch of stuff that kind of modern Java, Java 21, Java 22 does that you couldn't do back in the day. You had to have libraries around. And one of the big points for us was we want to start modern and we want to stay modern. We're not going to be, how old of a version of Java do we support? We're like, no, we support Java 21. That's our minimum, right? We want to use everything Java has to offer today and not be held back by all this old stuff. It's always kind of dragging people back in that regard. So everything has a minimum Java requirement of Java 21, and we're using all the new features of a language. So there's a bunch of stuff Java does today that it didn't do. And so we're kind of freed from some of those Apache libraries that in the past you always had to use to make HTTP calls or do XML, manipulation, a lot of the parallel threading and stuff. That's all part of their concurrent libraries now. We just tap into those things directly in the core. And since we're not worrying about supporting all these old versions of Java, that was able to really lighten the load on the number of third-party libraries we needed, because there's so much stuff just built into Java nowadays. And that was a really big difference for us, just to keep everything just as simple and close to the core of Java as possible.
So does that, I'm sort of hearing it only works with Oracle Java, no other JVMs are supported. Is that true?
All the JVMs based on Oracle Java, which is all the JVMs.
So in theory, it would work with other ones?
So here's the thing. Oracle's the company pushing Java forward, but all the open JDKs out there are all a few commits behind, Oracle's Java. So yeah, you can use BoxLang with any of the distributions of Java. So there's no requirement to use Oracle. And honestly, that's very typical of pretty much any other JVM language out there. They're certified to work on any version of Java, no matter whether it's, Adoptium or, Corretto or Azul, whatever it is, you can bundle that. We have an installer that'll get, Java for you. You can also, package it with whatever version you want. So we want to keep that easy so people can always, they can stay on an upgrade path and always be updating their Java and not getting behind.
Mm-hmm. So as long as the Java engine is based on Oracle version 21 or higher, they should be okay running BoxLang on it.
Yeah.
Sounds good. So any other drastic architecture differences? We talked about a whole bunch there, but were there any you missed out that we want to highlight?
Well, there's like a billion, but I don't know how many are pertinent to get into. The other biggest one we have is really around our parser and around our AST. I don't want to get too far off the weeds because most people don't care about it, right? As long as they write the code and they save the file and they refresh the web page and the magical stuff works, they're like, whatever, I don't care, right? It's all part of the black box. But we did a bunch of work in the front end of this project. It was months before we even had really a working runtime, because we started with the parser and thinking about how that was going to work into the runtime. And so one of the huge sort of deviations we have is we sort of have a multi-parser system. And right now we have two main separate parsers. We're using Antler, which is an industry standard library for parsing code. Adobe ColdFusion appears to use Antler based on the jar files that they bundle. It's a very popular library. But we have two completely separate parsers. One that parses BoxLang code, which is based on and similar to ColdFusion, but has a bunch of extra features and dynamic language enhancements we've added to it. And then we have a second parser that parses ColdFusion code as it's defined today by Adobe and Lucy, including all of its little warts and peccadillos and odd things that it does. And this was our opportunity to say, there's a bunch of little kind of weird things that ColdFusion does that we wish it had never done. And we want to kind of be able to break that and say BoxLang fixes those, right? This is the way it should have been. We've gotten rid of kind of the cruft that shouldn't have been there. We fixed the things that were wrong. We've renamed the things that were never named correctly, right? And that's what the BoxLang parser does. But then we have a separate parser that'll still parse exactly ColdFusion as it is today, because compatibility and being able to take code as you have and just run it is obviously, very important. Otherwise, we'd have effectively, no users right away. But that all consolidates down to what's called the AST. And the AST is an abstract syntax tree. It's basically a collection of objects that represent your source code. And this is very common with programming languages. And so the AST doesn't necessarily track every curly brace and semicolon. It just tracks the fact that you have an if statement. And the condition looks for this variable. And then inside the if statement, you have 10 statements, and one is a try catch, which has these statements inside. And you have a while loop, right? You set a variable. The AST tracks basically what the code's doing at a high level. And whether or not you parse ColdFusion script or ColdFusion tags or BoxLang script or BoxLang tags, which is really sort of four separate, parsing avenues, you wind up with the same consolidated abstract syntax tree. And that's what we compile down to bytecode. So the runtime kind of exists down here, and it doesn't care what language you came in from, right? The runtime just has all the logic to run the code. But that allows us to break with compatibility. The problem Lucy always had, in my opinion, and I don't fault them for this, was they wanted to push ColdFusion forward. They wanted to do things ColdFusion wasn't doing, but they had to just bolt things onto the side of ColdFusion, which sort of diverged the language in multiple places at multiple times. And now you have like different flavors of ColdFusion and certain functions that only exist in one place, right? But then ColdFusion adds a function similar to Lucy, but they do it differently. And that was always a bit of a problem. The separate BoxLang parser allows us to innovate in breaking change ways, but over in the BoxLang parser, leaving the ColdFusion parser alone. So you can opt into playing around with the new BoxLang features by, switching your file from .cfm to .bxm or from CFC to .bx. And now you can use the BoxLang source code. And the other thing the abstract syntax tree gives us, which is quite frankly huge, is the ability to do linting and code quality and actual, syntax help in the IDE. We have, an entire extension for VS Code written with a running language server protocol, and it does all the syntax highlighting. And as you're typing the code, it's parsing it through our parser. And like any other language would, ColdFusion developers don't even know what they're missing sometimes. You type something wrong, you have an incorrect syntax, or even if you return a string from a function that says it's going to return a number, we can detect those things now. And we can do that by parsing through that abstract syntax tree that's generated, which is available to create all sorts of tooling. I have proofs of concept for replacements for the query param scanner, for the bar scope scanner, finding unescaped variables in HTML that aren't using, these sappy functions. There's all sorts of code quality detection we can do now based on that abstract syntax tree that can become command line tools, code checker type tools, IDE tooling. And that's never been available in any sort of open source way. Lucy doesn't really have an AST. It just does like a custom built parser straight to bytecode, really fast, right? But it's not an extensible thing you can reuse. Adobe uses Antler, and they may have an AST. I'm not sure, but they're obviously closed source, so it's not something people can build on. With BoxLang, you can take our parser, our open source parser, our ASTs. You can extend it. There's interception points. You can write your own visitors that can say, don't allow variable names that have the word Brad in it, right? That's a few lines of code to be able to write a visitor for AST and create your own, code quality metrics. And that was one of those huge, missing black holes of functionality that CFers never really had. And we were like, we need to fill in this gap. We need to have the real IDE tooling. We need to have the real code quality metrics. We need to really have a parser that's, solid and allows us to innovate without screwing around and touching what ColdFusion is. Leave that alone. And so to answer your question from 5 minutes ago, I would say that's the other just really big architectural thing, is that we started from scratch and spent several months just nailing down what the parsers were going to look like. And then we also have the ability to take ColdFusion code in the ColdFusion syntax, and we can transpile that for you into the BoxLang syntax. So we've renamed the serialized JSON function to be JSON serialized, because that's what it should have been called in the first place, right? That's how ColdFusion works. You have the name of the data type, and you have the action you're performing. Struct append, array new, right? Query add should have been JSON serialized. So we fixed that name, but we fixed it in the BoxLang parser. So we even have tooling then. If you want to play around with BoxLang, you can give it a ColdFusion file, and we'll just go boop, and we'll convert it to BoxLang for you, which includes all the little renames and little syntax changes we've done. So we've made this easy kind of transitional bridge that you can just throw your ColdFusion code to BoxLang and say, run this, and it'll go, okay. Or you can say, you know what, I'm going to play around with some of the new syntax offered in the BoxLang parser, right? I want to be able to import Java classes directly and just use them, right? I want to have bridges for my functional interfaces, right? Like every other JVM language, but ColdFusion has. So you can take files, you can transpile them over to BoxLang, and then you can kind of easily switch between them. So the tooling around the parsing was something we knew we had to really nail from the beginning before we really even got into the runtime.
Well, that sounds really exciting, Brad. Thanks for explaining that. I just want to say for the folks listening at home that, as I understand this, correct me if I'm wrong here, all this fancy parsing and ATS does not affect runtime performance in one piece, because once it's compiled, it's in bytecode. None of that stuff is running in whatever.
That's exactly correct. Yeah. And so a lot of the transpilation we do is on the fly during the parsing phase. So when we parse ColdFusion code and we see you have a serialized JSON function, we swap that out with our compile time transpiler, and the bytecode no longer cares because we've already swapped the name out to the right name, and then it just runs as fast as possible.
Correct.
Yeah, and bytecode doesn't care about naming in the original language.
No. And like Brad said, tooling was hugely important for us. We wanted to make sure that not only you had a great language, right, but the tools are really, really important. And that's where the kind of like the CFML world has always failed, is because the tooling has also been subpar. So we really wanted to design to focus on tooling and bring it from day one, day zero, actually. So
maybe that can be maybe we can do a future episode about the opportunities in tooling, because I know we're on a limited time here.
And I didn't even mention the debugger. We have an entire stack debugger built.
I think that one deserves to be mentioned, which is the inline debugger. So this is line by line debugging that you can do in VS Code, from operating system code, from command box servers, from web servers, from any runtime. You can target the debugger and you can basically do line by line debugging.
Yeah,
easily. Let's put it that way.
You have introspection of your scopes, everything. We spent months on that, and it's all part of the VS Code extension that's out there.
And so that's something that third parties have built for ColdFusion, but they had to retrofit it. You've got it built in to the language.
Yeah, Adobe added some debugging functionality when they made their VS Code extension. Lucy has nothing in the core. There are some third-party libraries out there in the community. But it was important for us that it was made by us in the core as part of our, open source offering from the beginning. Right.
And then I just want to dig into that word transpiling, because people may not have heard that before. Does that mean it converts from one language to another? But I think also it means it's transparent. You don't have to transpile your code now you've lost your original code. You continue to edit in your legacy ColdFusion code if that's what turns you on, right? And you can run it in BoxLang, and as far as you're concerned, it's just
fine. So basically, there's two avenues. What you said is correct. There's a couple ways you can approach it. So you are correct. The transpiler is something that takes one language definition and then transforms it into another language, right? So BoxLang is very similar to ColdFusion, but still a distinct language. So if you run a ColdFusion file directly, we do the transpiler automatically for you behind the scenes as we parse and compile it. And once it hits the bytecode, it's all done. You don't really have to think about it. If you want to play around with writing in the BoxLang syntax and some of the new features that offers, you can do a one-time, transpiler command that will create, a copy of your file somewhere else in the new syntax. You can look at it and you can run that directly. So we have a couple different ways you can get to it based on whether or not people want to play around with the new features, or if they want to say, you know what, I don't care about that. I just want to take my ColdFusion as I have it today, and I just want it to run on BoxLang. That's also a totally valid scenario. And in that case, you don't really have to think about it. We just do it for you.
Okay, so two quick follow-ups there. First of all, what do you call the BoxLang language? Because I don't think you're calling it CFML. Is it BFML?
Yeah, just
calling it BoxLang.
BX is the acronym we use a lot. Like our file extensions are analogous to the ColdFusion file extensions. So a CFM file, we call that BXM for BoxLang markup. CFS, which Lucy 6 added support for, which is ColdFusion script, we have BXS for BoxLang script. And then a CFC file, which is a ColdFusion component, we just call that .bx just for BoxLang. We've made some terminology changes. One of the big things is we didn't want BoxLang to be a tag first language, which was always something that sort of haunted ColdFusion, was people saw ColdFusion as a tag based language and CF script as a bolt on. Now I never really saw it that way. I really thought CF script was a great, fully fledged language, but the way people viewed ColdFusion always had this kind of tag mentality hanging over it. And so we built the script parser in BoxLang first. It's the first thing we had working, right? We hadn't built any tags. We hadn't built any of the built-in functions, just pure scripts constructs, like if you're writing Java code, right? And that was the core of the language we built first, and everything else was added on along with it. So we use the word component now to refer to tags. So the CFHTP tag, you can use it in script. So was it really a tag? Yes, no. We just call that the component, the CFHTP component. Just a small little language change we made to try to distance ourselves from this tag-based mentality. And so ColdFusion components use the word component. We just call those classes now. So the BX file,
like every other language in the world.
Yeah, we're like, let's just match every other language, like literally in the world, and let's just call it a class, right? That's what we use. That's the word we'd use today if we were making a language from scratch. We'll just call it a class. So BX files, we just call that a class. We don't call them components anymore. Still works the same. And a small example of one of the tiny syntax changes we've made is class files in BoxLang don't use the keyword component, they use the keyword class, which is what you would expect in Java or Kotlin or most other languages. We've added real quote unquote annotations, so you don't have to put them inside the comments anymore. There's lots of little, enhancements that we've done, but a lot of it just has to go with the way we sell BoxLang, because we don't want just ColdFusion developers running their ColdFusion code on BoxLang. We want a language that Java developers or Groovy developers or no developers can say, hey, this looks like a fun dynamic language. I'm a JVM. I want to learn this. And, just like I would learn Python or Rust or some other, fun language to build things in. And we want to make sure that we market it in a way that sounds modern and sounds scripty and sounds, dynamic. And we don't want to focus on the tag first mentality or the legacy first mentality. And so that's always just been important. So we kind of have several rules of thumb, which is, well, how would we do it if we did it the way that, good language design would be in 2024, right? Not how does ColdFusion do it? How would we want to do it? What makes sense? And then how do we support that? And then also have the ability to transpile whatever ColdFusion does. And in some cases, we're like, you know what? We love how ColdFusion does this. There's nothing wrong with it. And we're going to do the same thing. Everything's really a case by case basis on, what really made sense in ColdFusion, what didn't make sense, where do we diverge and how do we still support everything?
Yeah, I mean, we even in our docs we're calling this the templating language, the BoxLang templating language, and I think that's what it really is. Just like ColdFusion has a templating language, or other languages have a templating language, like Groovy, for example, which has the GSP, right? So that's where we're headed in that sense, is to say, no, we have classes and we have the templating language. The functionality comes through modules and components.
Get detailed show notes on today's episode in your free CF Alive Modern ColdFusion Guide at teratech.com. That is teratech.com. Viva la CF Alive Revolution!
All right, so let me ask you this. I transpile permanently my ColdFusion code into BoxLang. Can I go backwards if I want to go back to the ColdFusion syntax for whatever reason?
Well, sure.
Or
And
am
we
I
don't.
stuck now
The
in
transpiler
BoxLang
tool doesn't
land?
delete your ColdFusion code. You still have
No.
it.
You still have your code.
No, but no,
We just
suppose
print a new
I've
code.
converted it and now I've
Yeah.
edited in BoxLang, and for whatever reason I want to get it back into CFML.
Oh.
Can I currently do that or no?
You can
No.
make
So
those
one
edits
way-
back in the ColdFusion files if you'd like.
Not right
Oh.
now, or you can get a license and get support, and maybe we'll build a module for you to go backwards in
All
time.
right, so it's technically possible to do that. You just haven't implemented it yet. If there's demand or people pay for it, they can have that.
Correct. I don't think it's in
Currently,
our
so-
best interest to create it, though.
I would argue that, because if someone's experimenting, they want, usually with more open products, you can export your quotes data, in this case your code, back out. You're not locked in. So I'm just proposing that, but it's your language. You do what you
Well,
want.
here's the
Well-
thing. You can write a BoxLang module right now, and you can put it on ForgeBox, and it can listen to our parse interception point, and it can take the AST, and you can write a pretty printer that prints out ColdFusion. You can do it right now. It's open source.
Oh, cool.
Because that's
Right,
basically
so
all our
open source, that's
transpiler
true.
is we take the AST and we put it through a BoxLang pretty printer. So
Yeah, and to be fair, the BX language, it looks like ColdFusion script to me.
yeah, the
I know you pointed
scripting
out.
syntax is very, very similar. Most of what we
Right.
added are just additional features. We have an instance of operator like Java. We have a cast as operator. I don't want to say like SQL, but along the same vein. We have like real annotations, like an @sign annotation name above functions, properties, and classes. We have just a handful of things that are just things
Lambdas.
doesn't do. The base script is very similar, and the tag based script is also quite similar. But instead of using CF, we use BX colon as the prefix for our tags. So yeah, I mean, there's not a huge departure from ColdFusion. A lot of the things we did was honestly like cleaning up and renaming, bits that just seemed a bit sloppy or didn't seem cohesive. And obviously, we have the benefit of looking back through time, and looking at that like 800 built-in functions, and that's not an exaggeration. It's literally more than 800 built-in functions.
I know.
In
I used to have this
ColdFusion,
cute
and-
poster with all of them on.
yeah, and so we have the benefit of looking back through history and seeing it all at once and saying, yeah, these here didn't really follow the right naming convention, and so we can fix that now. We can start from scratch and make it make sense.
So let's just step back from these technical details, which have been wonderful to talk about. I want to ask, what is BoxLang really?
So let's put it in 2 words. So we've gone through the whole language portions of it, right? So it's a complete JVM dynamic language, right? 100% interoperable with Java, which we haven't really talked about much, but it's completely interoperable with Java. So that means that you literally almost code like Java. There's no bridges like that exist on current CFML engines, right? We wanted to burn those bridges. We wanted to have full ability to import Java classes easily, to declare interfaces easily, extend from Java classes, implement from Java classes, everything that a dynamic language based on the JVM should do, right? So all that is there as a language. Second of all, we've built a lot of framework capabilities into the language itself. Mostly, we've been doing frameworks and building frameworks with Brad for over 18 years. And a lot of that experience has seeped into BoxLang to make your life productive. And this is really what the the ethos of ColdFusion was, right? To make you productive, right? And that's still our ethos, right? That's where we were born from, right? From ColdFusion. So all that is there, and we wanted to keep that productivity, but take it to even further levels, right? So you will find that in BoxLang, you have tons of these framework-like capabilities. Example, event-driven programming, right? This has been huge in other languages. This is core to the language. Everything can be extended through events and interception points. You can listen to a CFC to a class when it's created. You can listen to when a caching element is being removed from the caching engines, right? Like Brad said, parser events as well. And all these events are available to developers to finally extend everything without basically touching kind of the core functionalities, right? Even the dump, for example, the dump capabilities, right? You can listen to the dump capabilities, which we're building a module right now, that you're going to stream all the dumps into VS Code and actually have a panel seeing all the dumps from your live web application going into VS Code so you can analyze them and view them, right? So that's one example. The other one is the caching engine, right? I built Cachebox almost 15 years ago, right? As a caching engine, enterprise caching engine with distribution capabilities, ability to have an agnostic API to tap into other caching engines that has been ported in, right? So you have a full enterprise caching engine already built into the language and extensible or, through different cache portions to other engines like Redis and Couchbase, and that we will also be bringing pretty soon here, right? So it's bringing a lot of those capabilities. Another major one is asynchronous and parallel computing. That's built in thanks to all the features of the JVM. This is nowhere near to what the other CFML engines have done. We have really innovated in the area of asynchronous and parallel computing because the JVM has moved forward that. And we've been able to bring that into BoxLang as a framework capability so you can very easily create asynchronous computations and create functional stories around parallel programming, right? And that basically built into the other framework capabilities like scheduling, right? So, obviously, ColdFusion and Lucy have done schedule tasks, right? That have their cons and pros. The majority of them are using, for example, the Quartz engines, which is something that is built by Java developers, right? But we built one for ColdBox a long time ago, and we've been able to port that into the language as well. So developers can have really a nice, easy of use of building scheduled tasks without the need of a web server, right? You can source control your tasks, you can describe your tasks, you can program your tasks, you can unit test your tasks, which were incredibly important to us, right? And now you have all those framework capabilities built in, right? So those are just quite a few examples. There's many, many more that we can point out. But like you said, what is BoxLang? I think it's multifaceted, right? It's the language, right, that gives you, just like any other modern language built to today, probably further than any other language that we've done in the JVM, because we basically extend everything in the JDK, and the framework capabilities of the language, right, to bring true the ethos of ColdFusion of productivity. So those are kind of the two facets that we focused on and will be focusing on.
So you're saying it's a more modern language, not just than Adobe or Lucy CFML. It's more modern than all the other JVM languages out there.
So I'll give you an example on that one. Invoke Dynamic was a feature that was introduced into the JDK around JDK 8, right, Brad?
6 or 7, I think.
Yeah. So it was basically the capability that the language engineers at Oracle introduced into the Java virtual machine for dynamic languages, things that are not built using static constructs. And this was the new way to basically build upon on the JVM for dynamic languages. Only quite a few have adapted a few things from it, right? Kotlin has adapted a few things in their approach, even though they're not a dynamic language, they're static language. I know, what's the one that Sean Corfield uses, Brad? Scala has few. Clojure. Clojure has a few delvings into Invoke Dynamic, but we have really adapted it, right? And I think that's been our biggest advantage here to bring performance, speed, and really sticking true to what the Java developers, when they created Invoke Dynamic which was the initial, purpose of it, which is to use dynamic approaches. And we've taken that and built an entire framework that we call dynamic object. And this is really, really new in any language on the JVM, which basically allows us to treat any class. It doesn't matter if it's actually coming from a Python loaded JVM class or a BoxLang class, or actually even a Lucy class or whatever class. We can wrap any class into a dynamic object, and we can treat it as a dynamic construct, right? And this has allowed us to do even things that we never saw possible before, right? In ColdFusion and in other languages. And Brad can speak a little bit more because I developed the framework and he's been adapting it and using it. And it has been a thing that we've innovated that is very rare still in other languages.
Yeah, and there's a lot of performance capabilities that comes with using the invoked dynamic as well. Because Lucy and Adobe are still using Java Reflection for all of this. And Java Reflection is as old as Java version 1 or 2. And so that's one of the big architectural changes we wanted to do, was say all of our dynamic, anytime you call a method in a Java class, things like that, we want to make sure we're doing it the way that Java wants us to do in, using the modern practices. So it's opened up a lot of doors there.
Very exciting. So, do you guys have a comparison chart between BoxLang and not just Adobe ColdFusion and Lucy, but like Groovy and Rust and Clotcher and all these other ones you've mentioned? Or is that something you might have in the future if you don't have it now?
We will have it. We will have it in the future. We're still developing a bunch of these things to do comparisons and when people want to compare things. So we do. We're creating it as we speak. I have a document that Jorge sent me actually this morning of several of the different value propositions coming from other languages. And so we're trying to do our due diligence so people can see that and can see the benefits of the languages right now. Consider this, modern day today, there's not a lot of differences in semantics between languages, right? If statements are if statements, for loops are for loops, closures are closures, classes are classes. I think the major differences for us, and especially
why is that? Why aren't because there used to be, we had Lisp and we had Fortran, and they were wildly different. Like nowadays, cars. Languages all seem much for muchness.
Yeah, well, it's like vehicles, right? We have 1,000 brands.
Well, that's a whole other discussion. Why are all cars more or less the same? Well, I mean, where's the personality?
Right. So, Tim, that's a good analogy, though, right? So, I mean, you could say the API for driving most cars is very similar. You have a gas pedal on the right, you have a brake pedal in the middle, you might have a clutch on the left, right? You have a steering wheel, you turn it to the left, you go left, turn it to the right, you go right. You probably have a gear shift, right? Somewhere, some sort of button you push, key you turn. The radio probably has similar volume knobs. Those are creature comforts and what you expect when you sit down in a car and you feel like you can be productive driving the car.
But how many of those are really the best ergonomics? Like the QWERTY keyboard, it was designed to be unergonomic, right? And I think some of those car interfaces
I
actually
think most
were not
of those
the best
things
choice.
Have developed because they were the most ergonomic, right? I mean, used to be you had your high beam switch in the floor, you had to push it with your foot, but most of the time that's on the tree now. But here's the point: that doesn't mean that every car engine runs the same, right? Because when you push the gas pedal behind the scenes, there can be all sorts of differences between what's actually happening. And so I don't know if these are public or not. If you have a chance, Kai Koenig did a really good talk on BoxLang. We had no clue what he was even going to say in it at CF Camp. And he talked about this. He talked about how most languages have the same basic constructs, but how the differences between languages, what makes some languages better, more popular, and more successful, really boils down to things like the community, things like the tooling, things like the IDE capabilities. There was more of the peripheral things that really make some languages more successful and more convenient and easier to code in than just the fact that you have a for loop. I thought that was a really good comparison.
Yeah, and I think that was what nailed it, right? Is what really made ColdFusion productive, right? Is that other things that are not just the language, right? And
absolutely.
I think
ecosystem community.
Exactly. And
you guys
that's
really
our big focus.
And you guys have really contributed to the ecosystem and to the community. So thanks for doing that.
Yeah.
Really,
so that's really
invigorated ColdFusion.
What like you said is like this is our main differentiator, right? Is the framework capabilities. We've been built, the entire Ortus team is involved. It's not only one person, right? There's over 15 developers involved in BoxLang with their different responsibilities and different areas of interest. And everybody brings to the table of all their experience through 18 years of building over 350 open source libraries that we still manage and will continue to manage, right? So I think that's something that's really our differentiator for us, is not only is it a language, but is the framework capabilities and productivity capabilities that we want to bring, not only to the core, but through modules, through that community, and foster that community so anybody can be building modularities and grow the ecosystem.
Now, I know we're running out of time here for this episode. We're happy to have you come back and talk more about other aspects. Very exciting development in ColdFusion land. I've got a few quick questions that people are asking out in the ColdFusion community. Firstly, is Adobe ColdFusion or Lucy somehow embedded in BoxLang? There seems to be a misunderstanding here, perhaps.
Yeah, I think we've asked that question before, and the answer is no. Obviously, Adobe is closed source, so we have nothing to do with them. And Lucy as well, even though they're open source, our approach was completely different. So there might be certain things that were inspired from both engines in terms of functionality, but no, there's nothing embedded. Our CFML capabilities are because we built our CFML parser from scratch, and all the runtimes has been built from scratch. And you can even go to GitHub and see the entire history of the repository, and you will see how we started with 2 files and grown to over 3,500 tests, right, Brad?
Or more? Oh, no. We're over 6,000 tests now.
Ooh, sweet.
Yeah, I'd have to look, but I think this is still true. When we announced BoxLang in May, we had more tests than we had commits in the repo. So we have had unit tests on all of BoxLang from the very beginning. We've added a ton. We have thousands and thousands of tests, and we plan to keep adding.
So although you have extensive knowledge of what Adobe ColdFusion does, you never really saw the source code inside because it's closed source. And although Lucy is open source, you separated your development. You kind of had a Chinese, wall separation, like we say in the financial industry. You didn't cheat and copy from Lucy. You created, and you didn't want to, because you wanted to just have a fresh start.
I think that if we wanted to, we would have just forked it. And we actually analyzed.
Why didn't you fork it?
Well, that's a good question.
Yeah, so, tell us why you didn't just fork it. Lucy is open source. They'd have been happy for you to fork it. Well,
exactly.
Moderately happy.
So, well, we actually analyzed it for over a month and a half, the entire source code. Okay, I'm not going to say line by line, but the majority of it we analyzed internally, and we created a feasibility study, right? So we actually dedicated 2 resources to this to basically do a full analysis of what it would take to do a fork, right? The conclusion of our analysis was, first of all, it was completely bound to a servlet, right? The historical aspects of it and the decisions made on that project are made by one person alone. And there's really not a lot of documentation to guide us, to really propel us on why this, why that, right? We wanted industry standards for our parsing mechanisms. We didn't want something that was homegrown. That was another differentiator. Okay? The decision to use OSGI is something that we knew after being a reality that was not the correct decision to use. So it basically boiled down that we weren't checking any checkboxes on a reason to do it. Right. Plus, we really wanted to focus on really a tiny approach to it. And we wanted to use Invoke Dynamic to build the bridges for dynamic languages. So basically, after our conclusion was that it would take us even longer if we forked, because we would have basically just dismembered it on day 1. Right. We would have basically
what we wanted to do with it. It would have had to have looked completely different. That was the whole point.
So the consensus was that it's not in our best interest to fork it. It's in our best interest if we design it like we want to design it and focus on what a 2024 language would look like from here to the next 30, 50, 100 years.
And dumb question, why not just suggest all these improvements to Adobe?
We have. I mean, been actually, we've had tremendously, and let's not get Brad started on this one. He laughs, but we have
hundreds of tickets in the backlog.
And we've been very stern with them for years and years of what we needed to do as a community to really evolve, right? And go to the next approaches. And it hasn't happened. So, it gets to a point where, if you try to do the same thing, it's called insanity, right? So we wanted to break off of that insanity. And you can see the majority of things that are built right now in BoxLang, there are tickets for those in both trackers, Lucy and Adobe.
Yeah.
There's 10, a lot of 12, 15 years.
We have implemented in BoxLang now, and I can show you the tickets that have been for years and years in the other bug trackers. And there becomes a point where, we say, we need to be able to nest exceptions when we throw them, right? We need to be able to, have these JVM interoperabilities, extended Java classes. And we've been asking for years and years, and we can't be held back any longer. We need to be able to push forward. And if we have to build that in order to do it, then we're going to build it, right?
Yeah. And I think that was another major issue, is that we want fast innovation. I think this is the way of the world now. We need to be able to be quick. We need to be able to be agile. We cannot be waiting for 2 years, 3 years for innovation to come. Right now we're on our 15th release. 15th release that we've done for BoxLang. Every Friday there is a new release. So the speed of innovation and the speed
every Friday
for the last
15
weeks
or so releases every year.
Yes, and this has been proven to be great.
But this is like a part release, right? These are beta releases or something.
Correct.
Are you intending to have a weekly release cycle once it's in production?
I don't think, why not? I think that we're used to it by now.
Well, like Lucy does now, we've always had instant snapshot releases. And that was always a good thing about Lucy was, if you put in a bug and it gets fixed, and you can test it like that day, right? With Adobe, sometimes the ticket may be closed and it may be months before you even have a chance to test it, unless they send you a custom hotfix jar. And so we've always we have an entire CI process spread across all of our repositories, and everything gets immediately built and deployed. And, if we fix something reported in Slack right then, you can test it 15 minutes later. And so, the weekly betas basically just give people kind of stopping points they can pin to, and they can test that they know aren't going to, change.
Correct. Does this tie into ColdBox for versioning or command box?
We always use semantic versioning for everything that we do, right? And moving forward, that's what we'll continue always to do with all our products, right? Command box will be part of BoxLang.
Excellent. Very exciting. Well, I have like 300 other questions to ask, but we'll have to save those for a future episode, because I know, Luis, you have a hard stop. What are you looking forward to at CF Summit next week?
I'm looking forward to seeing everybody. I'm teaching a class this coming Saturday and Sunday. We're going to be building RESTful services with ColdBox, so that's always exciting. So I'm very excited to see everybody in CF Summit. I don't know if some of the Adobe folks are going to be excited to see me, but we'll see.
Of course they will. Very friendly.
I'm excited.
And can people ask you more questions about BoxLang when you're there?
Yeah, for sure. I want to be as full of integrity as possible. I'm not there to go promote BoxLang. Obviously, right? It's an Adobe event. So I want to be very, very cautious about it. So if you do have questions about it, just pull me aside, right? I want to be respectful of everybody's time and my presence as well, as respectful as I can in that sense. So,
how about you, Brad? What are you? You're going to CF Summit. I think I saw you might be speaking.
No, I actually didn't get any. I only submitted one talk, and they didn't accept it this year. So this will be the first year ever. I'm not speaking at an in-person CF Summit. So.
Well, you're more available for hallway track conversations.
We'll see.
He's gonna stay coding in BoxLang.
Yeah.
All right. Where can people find BoxLang online? Where would they go?
So they can go to boxlang.io. Very easy. And they can see pretty much everything that we have there. Not only the open source version, but the commercial versions are available there in terms of what we offer as well. They can go to try.boxlang.io and actually try it. We have actually built a full online editor, and you can test BoxLang code online as well. This is analogous to TryCF, but we've actually built this using 2 runtimes. to showcase the power of BoxLang using AWS Lambdas and using command box servers. So you can go try that out and learn. And then we've written completely a whole new book. It's called boxlang.ortusbooks.com. It's still in process, but we've made a tremendous amount of progress already. So we're trying that every single feature is fully documented. You know us by now, and we love our documentation. So this will be a new book. Once we're completed, it will also go to Amazon, so you can be able to purchase it as well.
And then there's probably a GitHub repo, right, lurking around, which we'll dig up the URL for.
That is correct. And it will be github.com/ortus-boxlang. And that's our organization. And you can see all our repositories there as well.
Excellent. Well, thanks so much for coming on the show, both of you. Have a fabulous time at CF Summit in Las Vegas, and look forward to talking to you about BoxLang and other topics in the future.
Yes. Thank you so much. We really appreciate it.
Yeah. Thanks for having us.
Anytime.
This podcast is brought to you by TerraTech, the ColdFusion experts. Develop, secure, optimize. Get detailed show notes on today's episode and your free CF Alive Modern ColdFusion Guide at terratech.com. That is TERATECH.com. And now back to today's show.